Absolute value equations and inequality. We will learn how to solve the absolute value equations and absolute value inequalities. Okay, let's start with the definition of the absolute value. We will use this definition. It will help us to solve, to deal with the algebraic expressions as well. For example, for this minus 5, everyone knows it's positive 5. But let's apply the rule here. It's minus 5. And according to here, if a is negative, then it has to be negative a. So it has a is this. So you write minus a is minus 5, so we get plus 5. This is how we use the rule here. Now, this is important because if x is less than 0, then what is the absolute value of x? This is negative. And if the inside is negative, then you have to make minus x, according to this rule here. Okay, we have some properties of this. Okay, you'll see an application minus 5 and minus 5. This is minus 5 is less than 0, so you make minus 5. So it makes plus 5. The properties of the absolute value, it's always bigger than or equal to 0, and the absolute value of minus a and plus a are same. And you can, if there's a multiplication here, you can distribute the absolute value in multiplication. And if you have a fraction inside the absolute value, you can write it as the absolute value divided by the other absolute value. So you can distribute the absolute value to the numerator and the denominator. And of course, we assume here b is not 0. And we can interpret the absolute value between the distance between two numbers in the real line can be calculated by the absolute value of their differences. So, for example, you have a, you have b, and what is the distance between them? The distance between them is the absolute value of a minus b. So the distance is always positive. So the distance is also called the length of the line segment joining a and b. So here, the length of this one is equal to distance between them. Now, when you say the absolute value of x, you can write it as x minus 0. So it means the absolute value of x is the distance between x and 0. So you have 5 here and 0. Let's say minus 5 here. So when you say absolute value of minus 5, so it means this distance. And what's the absolute value of 5? It's also the distance to 0. You can interpret this as the distance between 0 and the number x. Now let's use this in this question. Find the distance between 3 and negative 2 on the real number line. So it's basically the distance between them is one number, the difference between them, the absolute value of the difference between them. When I say the difference, you can take the difference negative 2 minus 3, or you can say 3 minus 2. You can write as a minus b or b minus a. They are same distance. So since they are same, so there will be no difference. So the answer is 5. So you see here. Now, absolute value equations, this is the key information here. If the absolute value of an expression here, is equal to a, then this expression is equal to minus a or equal to a. And here, of course, we say we take a is bigger than 0. If a is not bigger than 0, so you say this is not possible, no solution. So if someone asks you, okay, what is the absolute value? Okay, what's the solution of this problem? So the absolute value of any real number is always positive. This cannot happen. So there is no x here. There is no solution for this problem. So here, if we have such thing, this has no solution. Now, for example, this absolute value of x equal to 4 has two solutions, minus 4 and 4. But if the question is this, find the solution of this absolute value of x equal to minus 4, it has no solution because absolute value cannot be equal to a negative number by its definition. Now, solve the equation x minus 3, the absolute value of x minus 3 equal to 8 algebraically and graphically. Algebraically, I think this is easy because here is the expression here. This e is equal to 8. So we have two things here, e equal to negative 8 or e equal to 8. So what is e here? X minus 3. And then you solve both, and you got minus 5 here, and you got here 11. So these are the two solutions algebraically. And graphically, what does this mean? This means the distance between x and 3 is 8. It means this. So you have 3 here. You want to take an x value. So an x value whose distance is 8 here. What is x? X should be 11, and you can do the same thing here. You will make the distance, and here x can be what? So if you go this way, it has to be minus 5. So algebraically and geometrically or graphically, we get these two solutions again. Yeah, here, as it says here, we have two implications, two equations we got. They give two solution sets, and also in the geometrically or graphically, we are talking about the x values that has distance 8 to 3. The distance will be 8. So it might be minus 5 and 11, and we got the same thing. Now, solving an absolute value equation. Again, the idea is, you see the idea that E is equal to, let's say, A. Then we have two options. A is equal to, E is equal to A, or E is equal to minus A. So then we have 2x equal to 5 or 2x equal to minus 5. Then you solve them, and it gives you 3 or minus 2, and you take all these solutions in solution set. Now let's try to do this one. Absolute value of 1 minus 3x equal to 7. Okay, we have two options. One is this. The other is 1 minus 3x equal to minus 7. So let's solve this one. Okay, I can send it to here. Negative 3x equal to 6, and divide both sides with negative 3. So x equal to minus 2. That's one solution. And I can do the same thing here. Send 1 to the other side, it will be negative 3x equal to 8. divide by -3. Let's see, x will be 8/3. Okay, so the solution set is -2 and 8/3 for this equation. Okay. Now we have another example. Okay, in this example, we don't have a straightforward equation. We have some absolute value here and absolute value here, and they're same, right? They're same, or similar terms. Now, what should we do? We collect all one side. These one side. We have to put one side, or one side, and the rest one side. Okay, let's try to do it. How can we do that? We send the terms to the other side, like we switch the terms. Okay, you can send this one to the other side here, and it will be, and you can send, okay, what happens when you send to the other side? You get 9 minus 3 x minus 1 plus 4x minus 1 plus 7. And then when you, okay, what is this? This is the common factor, مشترك عامل. So you say x minus 1 times 3 plus 4, so it will be plus 1. So you write here as plus 1 x minus 1. And then the rest is just send 9 to the other side, 9 to the other side, and you end up with minus 2. So we have an interesting situation here because we have an absolute value equal to a negative number. It's negative. So how can that be? An absolute value equal to a negative number, it cannot happen. So we say there is no solution. So because the absolute value of an expression is never negative, so it's not possible. We say there is no solution. So there is no solution for this equation. Now, let's look at the absolute value inequalities, the properties of absolute value inequalities. What are they? Okay. The first thing is the absolute value. If the absolute value of x is less than a, of course, we assume a is bigger than 0. It means x is bigger than minus a, or equal to a, less than or equal to a. So here, I mean, if you visualize it, absolute value of x less than or equal to a means set, which means x is less than or equal to a and bigger than or equal to minus a. Now, when it comes to bigger than, it will be, it's bigger than a or equal to a, or x is less than or equal to minus a. So we have this case. When we say absolute value of x is bigger than a or equal to a, so we take this part, or we take this part. Because, for example, assume you say x is bigger than 5. So when you take x equal to negative 6, it satisfies the equation, right? And also if you take 6, it satisfies the equation. So 6, okay, when it is, you put minus 5 here, and 5 here, and when you pick any number here, 6, it satisfies the equation. And when you pick any number from here, I put negative 6, it satisfies the equation. So how can we write this one? We write the solution in interval notation this way, because there's a gap here, there's a gap. So you cannot combine them, so you write this way. Negative infinity to negative a, union a to infinity. And these, okay, might change depending on this or this, okay? So if we have them, we use the curly parentheses, okay? If we have equal sign, so we use the brackets. I mean, this is as usual. This is the usual application all the time, implementation. And also you can view this one as the absolute value of x. If you take it x minus 0, it means we are looking at the points whose distance to x is less than a. So you're taking the points, this is 0, you're taking the points whose distance is less than a. And for strict inequality, the result hold open intervals, not these, but these, okay? And x can be replaced by any algebraic expression, so we give this one with x, but this might be with other variables. Okay, let's look at this example. So we have to, okay, we will solve this one. This, you remember this one? It's less than 5 means less than or equal to, okay, it's between minus 5 and 5. Then you can put this 3x minus 1 here. And you are solving a double inequality here. Add 3x, 6, and minus 4, and divide by 3, and you get the solution. Okay, let's follow the slide, the solution in the slide. Add 1 to both, all sides, and then divide by 3, and then you got this one, and in interval notation, the solution is this. So as you see here, when we have these, we have this brackets here. Let's look at this exercise, the example. Now in this case, the absolute value is bigger than, so if you remember, if it is bigger than some number, you say E bigger than A, or E less than A, like minus A. Then you solve it, you get the interval, and you put the union here. Okay? Now, let's see how it is done. Okay, let's follow the solution here. So it has to be, okay, bigger than 7 or less than minus 7, as I told you. Use E bigger than 7 or E less than minus 7. So this E is 3 minus 2x. And solve it. Solve. When you solve it, you get these two equations. And then you can write them in interval notation. Okay, so don't forget when you divide with minus 2, you divide with minus 2, it changes the direction here. So we got this direction change, and the direction change here because of the minus division by minus 2, it changes the direction. Okay, be careful. You reverse the direction when dividing with negative value. And let's write the intervals. Okay, -2, infinity, union, 5 and bigger than 5, so it will be infinity. Yeah, it will be bigger than 5. So it's this one and this one, and there's a gap between them. So we put the union. So we don't combine them. Let's solve these inequalities. Look at this inequality. We have less than 9. So remember this. If the absolute value of an expression is less than 9, we have this double inequality. So for E, we have to write 3x plus 8, 3x plus 5, and then subtract 5 from each side, all sides. And divide all sides with 3, and no change in the direction. So these are strict inequalities. Strict, yeah, there's no equal to case. We write it with this parentheses, the brace, the parentheses, the curly parentheses. So the solution set is this one, the open interval. Now for the second equation, we have this. So we have bigger than or equal to case. Okay, remember this. If an expression is bigger than or equal to 8, so I'm saying this E expression. Now, then we have two cases here. E is bigger than or equal to 8, or E is less than or equal to minus 8. So now I will change this expression, 5 minus 3x bigger than or equal to 8, or 5 minus 3x is less than or equal to minus 8. Yeah, solve it. Okay, let's solve it. So we will get 3x here, sand and sand. So you got this one, and this will give us minus 3 less than or equal to 3x, and it will give us, okay, I want to change this one. I want to move this one to here, up. Okay, I have this one now, sand and sand. You got 5 plus 8 bigger than 3x, and this makes 13 less than or equal to 3x. So I got this one, minus 3 bigger than 3x, or 13 is less than 3x, and divide by 3 that x is less than minus 1, or divide by 3 x is bigger than 13. Over 3. Now minus 1 is less than or equal to x, is this set. Okay, minus 1 or equal or less than or equal to, so it's this one here. And this one here, x bigger than 13 over 3, bigger than, it's on the right side, and there's no limit, so it goes to infinity. So you say this is 13 over 3 to infinity, and there's a gap between them, so we cannot combine them. So the answer will be this. So the solution set is, okay, let's say is, so for this question the solution set is this one here.